Hello, today we're going to be reviewing the F equals to MA 2025 problem 4. So it says here that a mouse M is running from point A to point A prime with constant speed u1. A cat C is chasing the mouse with constant speed u2 and direction always towards the mouse. At a certain time, where MC is perpendicular to AA prime and the length of MC equals to L, what is the magnitude of the acceleration of the cat C? So today we're going to be making some uses of knowing the definition of velocity and acceleration with respect to time, and also you need a little bit of knowledge of some limits when it comes to trigonometric functions, as you'll see it later on. I'll explain these as we go along, and I might make a separate video just explaining how to prove these in case you don't have background knowledge on that already. Okay. So I get that this looks kind of complicated, but don't worry, I'll explain it step by step. Okay. So look at this diagram here. So this M1 is representing a location of time at which this mouse is standing. So in a certain distance del t, let's say that this mouse moves from M1 to M2. How much distance will he move? We already know his velocity is u1, and in a small time del t, he'll be moving a distance of u1 del t. We are also assuming that C1M1 has a distance of L, as that is what is given in the problem, and it's also orthogonal, as shown here. Meanwhile, C1 and C2 are changing as the constantly changing location of the cat. However, I also have a del theta included here, as we already know that theta is going to be constantly changing with time. As the mouse moves, the cat is going to be changing its direction as well. So what is the acceleration of the cat? The acceleration of the cat is going to be its final velocity minus its original velocity divided by del t. You're probably wondering, what are UF and UI, the two vectors that I have drawn here? UF is nothing but the velocity vector after a certain tiny amount of time, and the UI is the initial velocity vector before a certain tiny amount of time has passed, and you're going to be seeing these UI and UF can be defined for an infinitesimally small amount of time. Meanwhile, del theta is going to be tracking the small change in which the angle is going to be made from UF to UI, as while their magnitudes will be the same, their direction is going to be constantly changing, which is why there will be an acceleration in the first place. And this del theta is going to be so small that it can be pretty much rounded to 0. Make sure to keep this in mind because this will come in useful later on in the problem. Okay, so as we know, the acceleration of the cat is UF minus UI over del t, because that's just same as net final velocity minus initial velocity over time, which is the definition of acceleration. So as I put here, magnitude of UI equals to magnitude of UF equals to magnitude of U2. Just keep that in mind for now, okay? So this is a small snapshot in time in which the cat is moving with an original velocity of UI forward, and then it starts changing its direction to UF with a small change in angle as del theta. So what we want to do is we want to find the difference between these two vectors so we can divide that by del t. How are we going to do that? Well, as I said, as I've probably said in my channel description, I have said that you need to have some basic knowledge of vectors, so we'll be applying the parallelogram rule to find this value. If the forward direction upwards is UI, then that means the downwards direction should be negative UI, as direction also is a component in finding a vector. Meanwhile, if we can translate the vector VF so that its tail is at B instead of O, and move it to this dotted line over here, and so that its head is now P. So we want to find this vector OP, or more like its magnitude. We don't really need to know much about its direction. How do we do this? If this is del theta, these two angles should be the same since a parallelogram has a diagonals bisect its angles. Therefore, this angle will be equal to 90 minus del theta over 2. If this angle is 90 minus del theta over 2, then UF minus UI, we can apply the Pythagorean theorem by dropping a perpendicular here. I haven't really shown the work, so I'll just do it on screen now. We can drop the perpendicular. If this magnitude is after all magnitude of U2, this is 90 minus del theta over 2. So therefore, this is u2 times cosine of 90 minus del theta over 2. And multiplying this by 2, it will become 2 times u2 times cosine of 90 minus del theta over 2. Now let's simplify this trigonometric expression. Cosine of 90 minus del theta over 2 is the same as sine of del theta over 2. And since del theta is a really small angle that is so close to 0, we say in trigonometry that if sine of an angle is extremely close to 0, then sine of the angle virtually becomes that angle. If you don't know this, I might make it, as I said earlier, I might make a separate video for it earlier. And the same applies for tangent, as you'll see later in this problem as well. So I'm just going to give you a heads up. So OP will end up simplifying to 2 times u2 times del theta over 2, which simplifies to u2 times del theta. Okay, now that we know what uf minus ui, or OP, is, we need to now find that with respect to del t. Because we get that when we divide that expression, we get u2 times del theta over del t, but we don't know what this del theta over del t really is, do we? So we really need to find what that expression is before we can get our final answer. Well, how do we find this? We also can see in this problem that tangent of del theta equals to u1 del t divided by L. Now notice that these are both lengths, so we can just divide it like that. So that means that we just get that del theta equals to u1 del t over L, or del theta over del t equals to u1 over L. Now we can just plug this expression, as we now have found what del theta over del t is, and we can just plug this back into our original expression, which gives us that uv minus ui over del t is same as ut times del theta over del t, which is same as u2 times u1 over L, which is our final answer. Thank you.